I'd been building mics, and then about 96 or 97, I got into measuring acoustics of spaces, archaeological spaces. First started with a place called Ranigumha in Orissa, but then I've done many others. But one of the things, whether you're doing acoustics of spaces or anything, it's always what kind of mics do you use. Making a film, it's very simple. You know who you want to record and who you don't want to record. When you're doing measurements, you want to record everything that is there and then select what you need for your measurements. So, from the 70s, when it first came out, I had been very curious about this system called Ambisonics. Because what happened in the 70s, I think I have to give you, it's partly my history and partly history of audio as it happened. See, in 75, 76, a chap called Michael Gerson, he was a mathematics professor, also audio enthusiast. He got very irritated with all the nonsense that was going on in the name of 4-channel sound. Because that's a big peak for 4-channel sound. Basically, everybody thought if you can sell 2 more loudspeakers, how wonderful it is. And they didn't really look at how people listen, how 4 loudspeakers will work. So he is a mathematician. So he went all the way back to 18th century mathematics because that's where the best mathematics happened. And he devised a way of reconstructing the sound we hear. You know, we have only 2 ears, we don't need 4 ears. But we are able to tell if sound comes above or behind. You know, we don't have any ambiguity about it. You know where anybody is in the room at all times. So what is the source of this ability? You know, and he went into the maths of it. He wasn't going to say, I will, you know, people have tried all kinds of imitations of hearing, but none of them are really satisfactory. They have major handicaps. So what he did was, he went into what is how sound waves work on a sphere, and he came up with this thing for. I'm having trouble remembering today, but one of the things was that Helmholtz, I think. No, it's not Helmholtz. It is the other great German polymath. He did lots of things, including sound. He wasn't looking at sound. He was looking at vibration on a sphere, that's the surface of a sphere. And what Gerson did was to take that and use it for audio. And the way he worked it out is, if you have 4 microphones arranged in a tetrahedron, you can recreate the sound you would hear with a minimum of 4 loudspeakers, more the better. And he and a couple of others were all basically academics, built this microphone. That's what we are going to make. This is just the outer body that he has got. The inner ones, you don't have a working mic, no? You have the tetras. These are bodies. Inside will be a tetrahedron with 4 capsules. This is a tetrahedron. Okay? 4 microphones mounted on the planes of a tetrahedron. You know what a tetrahedron is? 4-sided. So these are the 4. So each side has got 1 capsule mounted. So there will be 4 capsules, and the wires will come out of it and go to a connector. This one is a second order, it's got more capsules. Yeah, it will slide in. It will be, it's not sliding in. So we can do something about it. We are anyway making new ones. This is too big. See, what happens is that is not important. That is basically protection for the mic, the body. But this is the mic. It's not a mic, it's 4 capsules arranged in a tetrahedron. The thing is, with even with very simple mathematics, just by adding 1 capsule and subtracting 3, you can create all kinds of directional patterns with just this. But with the real problem with that is only that every time you mount 4 capsules, there will be errors between the capsules. All capsules are not identical, especially low cost condenser capsules. They tend to be somewhat. So what they were doing in the 70s was they actually sat and measured and calibrated the mic, 1 mic at a time, and the correction was applied completely analog. So the circuitry was very large, it needed a lot of power, so it never took off outside BBC and academics. BBC would do some programs on as a, it was called surround sound, but the ordinary sound recordist found it too impractical. It was impractical, and for me, because I was interested in measurements and I wanted to be able to measure all 3 dimensions. See, one of the things with a mic like this, or with ambisonics generally, is that it doesn't have any preference for one direction. You know, any microphone, and in fact, you select normally a microphone that has a preference. It's a shotgun, it's a cardiac. They all will record well in one direction and not very well in the other direction. This is what we try to do with usual recordings. But when you want to do measurements and when you want to do anything more complex, you want to be able to record something that is same in all directions. And these 4 capsules, if you process them properly, you can just add them all up and you will get an omnidirectional microphone. But it's better than your usual omnidirectional because it's more, once you have calibrated it, it's more precise. It will have all 4, it doesn't have a front, back, sides, that kind of thing. So even as just a plain single omni mic, it's a very good mic. But if you take this, just give that to me, I'll use this demo thing. You see, if I make this my front and subtract these 3, it will become more directional than this itself will be. And you can control the amount of directionality. And the first thing we do is not to do a specific directionality, but you want to produce the basics, which is figure of 8 is, you see, in sound, we think of very directional mics and non-directional mics, but that's not the way it actually works. There are the omnidirectional microphones, which pick up sound from all directions. And then there are these microphones which pick up from, you use cardioids, and all those are derivative microphones. In terms of absolute microphones, you have what is called a figure of 8 microphone. It picks up sound from front and back and not anywhere else. And it's out of phase front and back. Now, when you say cardioid or any of these, it's a combination of an omni microphone and a figure of 8 microphone. If you add them and at different ratios, you can add all the other patterns. Well, those are not natural patterns. The known patterns are omni and figure of 8. So from this, one of the first things you do in your computation of patterns is to produce 3 figure of 8 microphones. That is one like this, and one like this, and one omni. See, the problem for Jerson when they was developing it, how do you put 4 microphones of 3 of one pattern and 1 of one pattern in the same space? They also have to be exactly in the same space. But with a tetrahedron, you can create those omnis. I'm just wondering if I have any of those here. Probably not. You can create 3 figure of 8 microphones and 1 omni microphone, all of them sitting in the same point, which is the theoretical requirement for the rest of it. So the next stage would be, as I said, you can just add all of these and you get the omni. You can take 1 figure of 8 facing up and down and the omni, and you get a mic facing this way. You can take a figure of 8 this way and an omni, and depending on how you mix it, you can make a directional mic in any angle. So with just 4 capsules, you are creating a very wide variety. I don't like using words like infinite variety, but a very large variety of directional properties. So that is the first stage in understanding ambisonics. So the second is, when you record anything with a mic like this and you process it with the 3 figure of 8s and omni, you can generate a playback signal which can be played from 4 loudspeakers or 2 or 16. But all you need is, it is just a mathematical process. You are not modifying the sound, you are adding and subtracting what you already recorded. So we don't have that here anymore, the multi-loudspeaker thing. You only have a pair. No, don't need. No, I wanted, what happens is, when you play back ambisonic sound, usually you play with at least 8 loudspeakers, more is better. And when you do this, and in the beginning, what happened in the beginning of this century was, we first got low-cost 4-channel recorders. Second, we got the mathematics. You see, the problem, as I said, is the electronics involved in doing it purely analog is so complex, and you have to, every year you have to take it to the studio and recalibrate everything. So in around 2000, I would say, let's say 2000 is the thing. Professor Angelo Farina in Italy, and there was this guy in Cooktown in Australia, and various people had all thought of the same sort of thing. Why don't you do it purely in software? So basically what I do now is I put the microphone capsules, wire it up, and connect it to a 4-channel recorder, and play sine sweeps. That's a signal that starts at the lowest frequency and goes to the highest. I play it in 8 directions, and in each direction I record all 4. From that, with a little bit of mathematics, I can derive 4 impulse responses, which I can then use on any recording I do with this mic to produce a signal that would have been recorded if I use 1 omni and 3 figure of 8s. Once I have that, there's a whole lot of software, mostly free, which allows you to manipulate and process these signals, so that you can, then you decide, I want 8 loudspeakers, you can make it 8 loudspeakers. Or you say, I want a very directional single speaker, you can do that into a single speaker. But it all becomes mathematical manipulation rather than audio manipulation. So you are really speaking, you can go back. For instance, a lot of the times people use these to produce a stereo recording. You have those recordings here, no? The ones I had given you of you don't have a computer, so he has got this thing. No, I had given a lot of samples of the recording. I don't have any on this, or at least I don't see any in this. So it doesn't matter, we don't have to. So I didn't plan to use them, but if they are there, I would have taken it out. And the other thing that happens is, because we've got a signal that essentially doesn't care which direction something is pointing, I can change the direction of the recording in the post. For instance, one of my favorite recordings is of a concert of Sarod and Tabla, for which I arrived too late. So I just put the recorder down in the middle and started recording. I didn't notice I placed it front to back. I realized after the recording started, but I wasn't going to change it. I just let it be. Well, I know I just have to rotate it, rotate the recording so front becomes back. It's the sort of thing that you can do. It gives you a lot of flexibility. And the other thing it does is, you could never get with the stereo recording or any of these Dolby. Dolby is a misleading thing because it works with film with a visual. Take the visual off, there's not much in it. So one of the problems with this is, you're sitting here and there's some music going on at the back. You turn around and listen to the music. It should sound the same if you are facing this way and listening to the music going on at the back. That happens with ambisonic recordings because the microphone onwards, at every stage we have preserved the sound in all directions. And one of the things that I wanted from this was that when I want to measure the acoustic properties of a space, let's say it's a small room. It doesn't have to be anything very elaborate. It's a small room and I want to record the properties of the space. I don't want to record a concert there. For that, the simplest is to put a microphone and a loudspeaker, about 2 meters apart. The loudspeaker ideally should be omnidirectional. I have a 12 speaker omnidirectional thing, dodecahedron, which I will set up in various parts of the room and record the sound coming, total sound into my microphone. And that essentially will tell me anytime I want to, what is the sound quality of that, because there's a lot of mathematics I can do from it. Second is, if I want to, I recorded in one room and then I have to do a voiceover in another room. And I would like to be able to use the sound quality of the first room. I can do that by processing the recording that I've done in the second room with the measurements in the first. It's a very powerful way of doing it. And I had done some recordings like that for instance, I recorded in Kerala. We wanted to record in the temple space, but they said no, you can't record here. So we recorded it in a rehearsal space, and I had the measurements from the temple because they allowed me to do that for 2 hours every day. They said no devotees will come at that time. You can come and do it. So I did the acoustic measurements of that space by putting my dodecahedron loudspeaker on the stage and putting my mic in different points and recording the 8-channel measurement. And so I could use that with the recording done. Because it's not easy to tell because it's drums. But even with that, you want the drums to sound like they were coming from the Kotambalam. I could process it and you could hear the difference. It sounds like it's coming from a place where I could not record. It's one very easy, useful thing. And for people like people haven't used it much in film, but it's one of the ways you can just record the ambience of a space, and then voiceovers, and you can process the voiceovers to sound like they're coming from that space. And for me, I was interested in the academic side of it. One of the things we have when we hear is that our hearing is very good for short term. You cannot, you can take 2 photographs and compare them. You cannot do 2 recordings and compare them. You don't remember the first recording by the time you heard the second. I was interested in the evolution of how we are producing sound and what we thought was good sound. I'm basically doing research into ancient acoustics, or the performance spaces. And how do I compare them? There's no comparison. I can produce large charts saying this is the reverberation time, this is the echo. but that doesn't tell me very much about how did it sound. And I went to about a half a dozen places at least where I did measurements. Till I did 3, I wasn't even sure if there's anything comparable between one and the other. The places themselves were not like each other. Ranigumpa is carved out of rock, and this Kutambalam is wood with a copper roof. And so each one of them has a different visual this thing. Was there any shared acoustic aesthetic? And you can't, it's not easy to do those things, but once you've done the recordings, and once you have the measurement recordings, you can take somebody to speak in front of a microphone inside a studio and process it for 5 minutes to come from Ranigumpa and for 5 minutes to come from Kuttampan, this Kerala place. And you can hear how they are different, how they are not different. It's one of the things you want to learn is how from 3rd century BC, that's Ranigumpa is about then, and this Kerala Kuttambalam, it has been rebuilt every few hundred years. It's built of wood. But one of the things I was looking at, what was the acoustic aesthetic from the beginning to around 13th, 14th century. Because after that, there's too much noise. You can't depend on, they couldn't do what they could do. A place like Ranigumpa, they really didn't have to worry about anything but the sound they were producing. And they seem to have carved it by the ear. They carved till it sounded right and stopped. And it's a very large space, it's not small. They took a mountain, cut half of it off, one half was converted to the theatre and the other half was audience space. The kind of extreme, these things that only kings of that time could do. You can't build like that. So, all these, you see, for in the 3rd space I looked at with some detail was Nagarjunakonda. It's about 4th, 5th century AD, not BC. And the place I was looking at was actually modeled on Greco-Roman amphitheaters, open space. But the moment you arrive there, you realize, hey, this sounds very much like Ranigumpa. They arrived at it through completely different means. Ranigumpa is carved into a mountain. This is open space, but parts of it are built up, and there's space for audience. And the built-up spaces were designed to produce, and also they built it on the edge of a mountain. So they were using the mountain slope as part of the reverberation. So they knew what they were doing, and the two things I was interested. You see, because things happen by accident. So I wasn't really interested in accidentally good sounding places. I was interested in places where there's very definitely and desire to create sound. Second is how similar are the acoustic desires. What did they want? What is the sound they thought was good? That's what you're really trying to do. See, I was once asked by some ASI boss if I could, he thought I was trying to listen to the sounds of the ancient people who built Ranigumpa. And while I was doing my measurements, he comes and asks me, "Can you hear them?" I said, "Hear what?" He thought I was actually listening to them. That's not what I was looking at. You see, because this is a misconception in a lot of people. They think I am trying to recreate. I am not. We are trying to reconstruct their aesthetic, not the actual, because we don't know what they actually did in that space. So that is what I was doing. That is the technical ambisonics, why I was doing. But what happened was, when I built my first ambisonic mic, which is actually a Zoom H2, on which I mounted this 4 capsule array. I sent it to Parma because Angelo Farina is the authority on these things. So he heard and he calibrated it in his he has got an anechoic chamber, a very large anechoic chamber, and did it measurements and that, and developed a system for using the measurements, and wrote back saying, I want 10 of these. So I made 10. That's where actually trying to make ambisonic mics begins. Okay. Then of course I started making them semi-commercially or commercially in Delhi, in Noida, and then I left Delhi and came to Bangalore, and I was wondering if I will be able to do it, because I'm also getting old. A lot of things that even good soldering, you can't do it when you're 80 years old. So, but I found that the girl who was working for me could actually learn. She learned to solder. She is good at soldering and good at building these things. So basically, it became a partnership between the two of us, and she goes around Cooktown, knows a place where there's a lathe guy and gets the lathe parts made. But we've been doing it like that. This mic was built like that. She did all the soldering. You can take it out and see. This is, I will come to the next stage of ambisonic microphone. Pull it out. You can't see anything except the cloth, because there are 8 capsules in this. Then what I did, then ambisonic theory, what I have been doing is first order, 4 capsules, 4 channels. But a lot of people had moved on, especially when it became more popular and a lot of musicians started using it. They wanted it output to large auditorium with 40 loudspeakers and things like that, where first order is not enough. It's not directional enough. The directions are not sharp enough. So from that, the thing is, with musicians, a lot of the music is not recorded live. It is done on paper. So, but there are at least a few people who want to be able to record this higher order ambisonics. This is a second order ambisonic microphone, which got 8 capsules in it, in a arrangement that's rather like an octahedron, but slightly different. And that is because there are 8 balanced cables coming out. So I have to provide 16 channels. The cable is there. So I have built up to third order now, 16 capsules. Luckily, they are not analog capsules, they are MEMS capsules. So the output is actually direct to USB. You can plug it. I didn't bring it because I didn't see any point in. So and then what happened was, bit by bit, I've been selling quite a few of these mics. We sold about 400 mics nearly, but over 8 years. And I'm not trying to push it, but that's why Yashish is going to make these new bodies. They are going to take over making these mics, because Meena does it, and she's pretty good at soldering and all that. But even with her, see, the thing is, there are 2 steps. The first, design is the first step. Forget it. I designed and done. I can make any number of copies for the next 20 years. Design won't change. But 2 steps after that. One is calibration, which we mount it on a rotating this thing, and take 16. For this, we measure 16 positions. Now it's settled, but in the beginning it took me some time to get it all right. And then those measurements have to be taken into a program called MATLAB, and you have to do some amount of computation to get the final outputs. The final outputs are, in this case, there will be 8 into 8 impulse responses as a single wave file. And you use that for processing your recordings. Because as I said, when you do a recording with a particular mic, we call it A format. Okay, first basic format. Then when you process it so that it becomes 3 figure of 8s and 1 omni, we call it B format. And the big advantage of B format is it doesn't matter which mic you recorded in, they are all compatible. So you could do half of it in one mic and the other half in another mic. Whereas the A format recording is very specific to the mic you have used. And these rules apply also to the larger, higher order like this one. But it needs a lot more work. It takes me a day to do the computation. And see, all these will become more difficult as time passes. Because I am now, this July I will be 79. So you have to think of what is going to happen afterwards. So I would like students to learn to do these things. You see, students from ISRO have built, modified a mic and they did some measurements with it of acoustic spaces. I'd like to do more of that so that they will do it rather than me. Because for me, even last time I went, that was about 5 years ago, I had trouble climbing those spaces. It's just physical effort. You have to get into some odd places. And one actually I couldn't make it at all. I sent others to do the measurements and I just listened to it on headphones to see what they were getting, which is not right. You should be able to do it yourself. And when you can't, you should let others do it rather than saying, I want to put my finger on it. So it is one of the things that's happened to ambisonics. And the other thing is, a lot of musicians, when they start using ambisonics, they're not using it in a mathematically pure way, which I would. They are going to use it as one element of their composition. And sometimes they don't even need acoustically recorded material, because they are going to do it entirely from, there is lots of software now that allows you to take a single microphone signal and feed it to any loudspeaker. Got 40 loudspeakers in the auditorium. You can feed it to any particular loudspeaker and you can move it from one loudspeaker to the other. So those are all tools of a performer, not of an acoustician. So it's going to have, this is what happened to sound. Edison wasn't a great sound recordist. It was an experiment he was doing. Whereas once sound recordists took over, it changes the way the mic was made, the requirements of the properties of the mic, how rugged it is, how reliable it is. All those things become more important, and people do. I don't know what will happen to ambisonics in, let's say, 10 years' time. First thing is, we are able to, especially with MEMS capsules and things like that, we are able to record many more tracks than, you see, with an analog this thing. 2 channels is about the limit. You can see the wire that's coming out of it. It's a fat wire. See, you don't, and it's very inconvenient, and it's also somewhat unreliable. Whereas a MEMS microphone with a USB output, it's very, you just plug it in and all 8 channels all 16 channels are working. And more and more, the MEMS has limitations, but we are able to manage those limitations now. And they're getting better, because in the beginning I wouldn't use MEMS for a music recording because it was too noisy. But now they're getting better. So all these things will happen. So we just watch and wait. I want other people to learn how to use these, how to, not just use but also to build. Because that's where the real limitation will always be, that there will be many more people who are ready to use a microphone if it is working, but won't know how it works. Okay. Huh? I don't think I can do any practical. I can connect up and we can listen to it on speakers directly from this is our output. But it's not really, because I'm not doing any calibration at all. I can connect it, see what it sounds like. That's it. I got an 8 loads. We can hook it up
Yeah, but maybe they can kind of learn how to
hook it up.
Yeah. You guys have used this before, right? Never? Not used this at all. You know what it is?
It's an 8-channel recorder.
So it's for recording audio, right? So you get and correct. So these are the ones that are used by professionals, right? So these are
This one can take 8 microphones.
yeah, this can take in 8 microphones, right? So yours will have just one. So this can take in 8, used primarily in film, for example, right? For shooting.
It can also be synchronized to the camera and all that.
Yeah, so you can connect this directly to your camera and get like timestamps, for example, right? So you know when someone's talking. So for today, I think what we can do is basically
Hook it up.
hook it up.
That is the microphone end. Disentangle the wire. The bane of sound recorders is the cable. I'll do it. They are numbered and all that, so it's not so complicated. The nice compact thing. Is the power being plugged in? No. Huh? Each one is for one microphone. But I don't use it like that because I lock them, so all of them will change simultaneously. That goes to the mic.
Yeah. So right now, where is the mic?
The mic is there with us.
Yeah.
Take it out. It will be marked 1 and 2. Rather, 1 to 4 and.
So the channels are marked 1, 4, and 5.
Yeah, you plug it in.
Make sure you go.
No, you have to rotate till it fits. Okay, go in. It should go smoothly in. What happened? A lot of people complain about not working, and what to discover is they have not been able to plug it in. I don't like these connectors very much, but I don't have an alternative. Okay? So this end, you put that down somewhere. These you can connect. They are numbered. 1 to 4 one side and this is one. Yeah. Capsule order.
You said there are four connectors and I can connect 4 mics to it, but I see 8.
Yeah, 1 to 4 and for that. No, because you, for instance, here we have got 8 on each, 4 on each.
Right.
But you won't get recorders sitting with those connectors. So you'll have to split it up. See, you'll get these. These will have 8 connectors here. In the studio, for instance, you won't get a single 8 jack thing. It's not practical for the recordist. Okay, is it powered? Power wire is going in. Where is the other end of it? Okay, there is 1 switch you have to press. No, you don't have to. What did you do?
It's connected, I think.
The bottom left corner, there's a front.
Yep.
There's a power switch. You hold it down.
Yep.
On?
Started up.
Okay, now can you hear all channels?
It says no car. Okay.
That's all right. You are not recording.
Just channel 1.
Hmm?
Just channel 1.
You change channel 1. Oh, only one is on. Okay. No, press the wrong button. I'm not seeing very clearly what I'm doing.
Okay.
Okay. We got all 8 channels. Can you see?
Yeah.
Can you see 8 meters moving? And now we can connect it to headphones, or we can connect headphones there, or you got a cable to connect to.
They're all Bluetooth.
What?
No, it doesn't connect with. It has aux.
Aux is all right. It's the same level now. Headphones and I also have line out auxiliary output. So all 8 channels are working happily. No, you want to connect to these, na? To these. Where is that? Yeah, you change direction, the mic levels will change. What is that for?
Oh, it's the
So
headphones.
Headphone out is here. Okay. Yeah. Now, if you change direction,
Can you?
huh?
I can't hear anything.
Oh, okay.
Oh, wait, mic. It's not on.
No, you don't need a mic there.
No, it's the headphones. Oh.
Hello? Not hear it? No, there's something wrong with the headphone.
Oh, it's not connected properly.
No, it should be the same both
I
ways.
need
How many pins?
no, the aux pin should be thin. to
No,
go inside.
so it should be the same.
So that's a proprietary cable.
Oh, I see. Then you can't use it.
Yeah, it's a proprietary cable. There.
Connected to anything else.
No headphones?
Yeah, you got another pair of headphones. Usually we eliminated proprietary connectors.
And still brands to like certain brands.
If you can put it on speakers, it might be more fun. Yeah? See, can you hear it this way? Direction changes, right? Hello? The headphone output is the bottom. This is the headphone level. Maximum level. Hello? What is that?
This speakers one. Can we connect this bin to that? Or it's just
You can connect direct. Yeah, there's also got an auxiliary output there.
Just can I connect this?
Yes, you can. Once
Head-
just leave that.
Okay.
The headphone.
Yes, you can directly. Yes.
Instead of that, you connect the headphone out.
The same.
Why? Why are you giving her that? That comes from somewhere.
It's not here.
No. Oh, you have to take out that connector. Now to go. Hello? Can you hear me? No, I can hear. Yeah? Hello?
Okay. Where is it? Behind?
Hello, it's working here, and that's headphone output. So you have. I use the headphone output for my measurements.
Yeah. No.
Hello? Yeah? I can hear it. I can hear it. Now what you do is you take this fat cable and take it away from the loudspeaker.
Okay.
So when you talk, see, that's why.
Hello.
Feedback, yeah.
Hello.
Okay.
Does it sound like can hear differently in the headphones or?
I mean, it's just one source.
Yeah, I know. No, you don't, but you can.
It has left channel and right channel. Does it like?
It can produce, headphones will produce left and right. But your output is going to one speaker.
Right.
That's
So
the
even
same.
if it's a left and right channel, it just feels like.
But then we can hear differently in that, right?
On the headphones, of course, they can hear.
Yeah, so do you want me to connect to the focus rate and record on the.
Are there 8 inputs there?
Yeah, there's 8 then.
Oh, then they can change over.
Okay, so let's do that. So open your.
What will you connect to? To that. Because you can connect on this thing, but it's giving trouble. That's USB cable to a laptop. But you need drivers, all kinds of
Everything
things.
is done. So can I sit here?
Just take the mics out, all the 8, and
So
put it into
basically what we are doing right now.
yeah, you have to take all the 8.
Sit here. So what we are doing right now is we're getting rid of this.
Put off the. You
and
can
then
put off the zoom.
and
In
working
fact.
with this.
Yeah.
That was different.
Yeah, that was it. Just hold it.
What's the difference between these two?
So this is meant to be portable. This cannot be a portable device. It always needs
But
to
they
be
do
connected.
essentially the same thing.
They do the same thing. Not the same. They are not the same.
They're not used for the same things, right? So these are used in the field. So it's a field.
See, you
that-
connect it, put it on your shoulder, and go and record in a mic like this.
So what you got to do now is unplug these
Yeah.
8 mics you plugged into this and plug it over here.
But that has.
There will be 2 here, so that might only be 6 at
It
the
has
back.
2 on the front. And
Yeah.
6
Put 1 and 2 here.
Put 1 and 2 here. Right?
They come out very smoothly. It's a good construction. This zoom. See, this is not fully in. Yes. You'll be very short.
Um,
That wire, why is it coming from here? Yeah, you don't need it. You're not using it anymore. You have to get your wire
Make sure
straight.
you plug it correctly.
Okay. Set are the levels set from.
That we just unplug from here, right? Back here.
Yeah, but we should be able to hear it now.
You might want to look at this. Learn how to do this. First, what you do is you come here and choose in preferences. You choose Scarlet. It shows up. It's called the Scarlet, right? So that is now your audio device. So, let's not worry about the rest. Okay. So we've chosen that. Now we have to choose each of these for each of these tracks. So I come here. Yeah. In fact, while you're recording, let's say you have 8 mics. One mic is recording a tabla, one mic is recording a sitar. Yeah, but then you would say tabla sitar.
so the current system has the capability to take in 8 mics.
Yes. Let's listen to this, how the way it was recorded. Okay, but I think that so we learn how to record, correct, with this and that. So now we have 8 tracks, yes. So we need, so since we have 8 tracks, we can configure the output any which way we want. We can send it to any speaker, we can rotate it, we can do all sorts of things. So there's various software, most of which are free, which allow you to do that. So, for example, here you see you can send it based on direction, height, etc. Right? So look here. So you have this 4 which you can move. That means you can move that output to yeah. So because we have just 2 that's connected right now, you might not. Actually not a good idea because it was moving while you were recording itself, right?
So you should not move it twice.
Yeah, you shouldn't do that, right? So if you had a static sound and then you could move it, and then okay. But I think today's workshop, the main idea was to understand that there is something called Ambisonics, which is being able to capture sound from a 360 field. How to do it practically using the field recorder. We recorded it with this also. This is like a bonus, but generally you would do this, when you're running outside.
Hello?
You take that and do that. And use this. We use the software called Paper. You've got 8 channels in. And then once you've got those 8 channels in, you can do multiple things.
தெரியாது டாலர்ஸ் தெரியும் ருபீஸ்ல தெரியாது
Yeah?
அது அவ்வளோ ஈஸி இல்லை பட்